Hi and good morning. So today we are going to see a lab on static route configuration. So to do this particular lab, first of all we would establish our topology. So we would have two routers for this particular lab. I will take a 1841 series router and two PCs on both the end to test my end-to-end PC communication once the static route has been established, and switches which helps me to manage the traffic between these devices. So let us quickly establish the cable connectivity between these devices. And the last one is outside. Yes. In the real-time scenario, when we are doing across a static route configuration, always remember we would have a ISP cloud in between, which helps us to give the end-to-end connectivity, that is from any source to any destination. But as we are doing this particular lab, you would consider that there is an ISP cloud which is present in this lab, but I would use a back-to-back serial cable for doing this particular lab. I'm not using any ISP cloud. You would just imagine that there is an ISP cloud between these two routers and we are trying to have a communication established. So we would take a serial cable and connect from one end of the router to the other end. And before doing that, first of all, we need to enable the serial interface module on the routers, because by default you would not get the serial interface on the 1841 routers. You need to fix that module separately. So you would do that by getting into physical configuration mode of the router, and I would physically turn off, because there is a logic for connecting the WIC pad that you need to turn off, and only then you will be able to connect your WIC interface into the router. But in the latest routers, whatever we get, you no need to switch off the router. There is an hot swapping option which is available. The router is turned on, still you connect a module or remove a module, there will be no issues. But as this is a simulator, we need to manually shut down, and only then we will be able to insert the WIC card. In case the router is on and you're trying to insert a WIC card, you will throw out an error saying that the module cannot be inserted when the device is powered on. So whenever you're doing the lab, please turn off the router and then insert the module. Only then you won't find any errors. So the same thing would be done on the other router also. So I would insert a WIC card and start the router. Right. So let us take a back-to-back serial cable and connect from this serial port to the other end of the serial port. So a back-to-back cable connection has been established between one router, from router 1 to router 2. So let us quickly decide the IP addresses which we are going to use in this particular lab. So for one end of the router, here I would use a 10 series IP address with /24 subnet mask. This would be my IP which I'm going to use for this side of the router, and the other end I would be using a 20 series IP address. So again it would be a /24 IP. So this side it would be 20 and this side it would be 10. So as I told you in the beginning of the lab, we would have an ISP between these two routers, but we are not having any ISP in this particular lab because it's a simulated one and we are using for a practice purpose. So we would consider that there is an ISP. I have connected a back-to-back cable, but even though if you connect a back-to-back cable, I need to give an IP for this. So I would take an IP subnet for this. That would be a 30 series IP with /24 subnet, and this I would consider as my ISP IP. So this 30 series IP address is provided by an ISP between these router to get interconnect. So let us now configure the devices with these IP addresses starting from PC. So PC would have the IP of 10 series, so 10.0.0.2 with the subnet mask of 255.55.55.0, and the default route would be 10.0.0.1. The same thing I would do on the other end of the PC also. So this would be 20 series 20.2 with a subnet mask of 255. So we are using /24. So we need to use 355s and 0, and our default route would be 20.0.0. Yeah. So the PCs are configured with the IP addresses. Let us quickly configure the routers also. So I would get into the CLI mode of the router. I would say enable configuration terminal interface fastnet 0/0, which is going to be my LAN. So there is a command here, something called as description. So I would give the description for this interface saying that it is my LAN network. So when you give the description for the interface, it becomes very easy for a LAN engineer or a WAN engineer to identify to which network this interface is associated to, whether it's a LAN network or a WAN network, or it is connected to a voice or any type of network when you give a description. So we have specified the description as LAN. Let us quickly give the IP address. So it will be 10.0.0.1 with 255.55.55.0 and a simple no shutdown. So as you see, the port has come up. Okay, as you give the command no shutdown, whenever you get a brand new router, all the interfaces in the router will be in a shutdown mode. So we need to manually give the command saying that no shutdown. So when you say no shutdown, automatically the port turns out and says it is not no more in a shutdown mode. It will turn into an active mode. So we have enabled the fast Ethernet. The same thing we will do it on the serial. So serial 0/1/0 and IP address. As I told, it's an ISP interface. So ISP IP what I took was 30 series. So it will be 30.0.0.1 with the subnet mask of 55.255.55.0, and I would say no shutdown. Okay, no shutdown. And once I give no shutdown, you see the interface state is still not turned up. As I told you in the in the beginning of the lab, we are going to use a back-to-back cable. So when you use a back-to-back cable, both the ends of the back-to-back cable has to be turned on. That is no shutdown. So once both the ends are turned on, only then the interface would come up. Until then, the interface would be in the shutdown mode itself. So we would specify the description also, saying that it is an ISP link. Okay, it's an ISP link, and I would say exit, and I would give a simple command coming back saying write to memory. So it saves the configuration into my flash. So the router 1 is being configured. One small thing which I forgot, that was the host name. So let us configure even the host name on this router. So it is named as R1. So the same thing we have to do it on the other end of the router. So we'll get into router 2, enable configuration terminal, host name as R2, interface fastnet 0/0, description would be my LAN network, IP address. As I told, we will be taking here the 20 series network. So it will be 20.0.0.1 with the subnet mask of 55.255.55.0. You would say no shutdown. So link comes up. And the same thing which we did on the other end for serial interface, serial 0/1/0, IP address. We used 30.1 on the other end, so here it would be 30.2 and the subnet mask of 55.55.0. Description, as we told, it is the ISP link, and no shutdown. Okay, now if you see, the port state has come up. So both the ends are turned on. Once you give no shutdown on both the end, only then the port comes up and you will be able to establish the connectivity. So if you see here, now everything is turned on green, so no ports are in red. So when it is in red, it specifies that the port is shut down or it is in non-functional state. When it comes to green, everything is fine, everything is in a functional state. So let us configure the static route command on both the routers so that they are able to interchange the information or exchange the information between these two routers. So again, you go back to configuration terminal and give a simple command IP route. We would specify an IP route. Why it is known as a static route? Because we need to manually configure the routes, who are my neighbors and who is going to exactly talk to me. So I need to specify from which interface the information is going to come to me. So the first thing is, let us understand who's my neighbor. So I am in router 1. I see my neighbor is 20 series network, and in case of 20 series network wants to talk to a 10 series network, they should come via a specific interface. So the interface which is going to send the traffic to 10 series would be interface serial 0/1/0 of R2. So any traffic, any 20 series traffic which wants to come and reach the 10 series, it has to come via the interface serial 0/1/0. So only then the router 1 would accept the traffic and it would say yes, this traffic can flow through me and it can reach the 10 series network. So let us specify that in the command IP route 20 series, that is 20 series network with a subnet mask of 255.255.0. If they want to reach me or if they want to come and talk to me, they should come via the interface or the IP address. So I would say the IP address which is associated to that interface is 30.0.02. You see this serial 0/1/0, we had given the IP address of 30.0.02. So whenever the traffic of 20 series wants to reach 10 series, the destination IP address or the source IP address should be 30.0.02. So only then it would the router 1 would accept the traffic and it would allow or pass through the traffic. So let us configure that command. So I would say show IP route 20.0.0 with subnet mask of 255.255. It should come via 30.0.0.2 and just click on enter. So the command is being accepted. So how do you test this command, whether it is being configured or not? So you give another command called show IP route. You say show IP route. So it opens the routing table. So in the routing table, if you see, there are two interfaces. One is 10 series, the other one is 30 series. And if you see before these interface IP addresses, there is something called C and C. So what is C? C says it is connected or it is directly connected interface IP addresses. So 10 series is also directly connected IP, which is connected to fastnet 0/0, and 30 series is also a directly connected network which is associated to serial 0/1/0. So there is a third one over here, something called S for the 20 series network, which is nothing but some called as static route. So here if you see the top definition is there, it is static. When it says it's a static route, where we are seeing in case if 20 series wants to reach 10 series, it should come via 30.0.0. And how many hops it is away? It is just one hop away. So how many hops in the sense, if 10 series wants to reach 20 series, it needs to cross only one router away. So it is just one hop away or one router away. So the R1 is configured. So the same thing we would do on the R2. Configuration terminal IP route 10 series with 55.55.0 with 30.0.01. Okay, so when 10 series wants to come and talk to 20 series, it should come via 30.0.0.1. So save the configurations, same command show IP route to check whether everything has been configured. If you see, the same information will be provided. So there it was 20, here it is 10. Only thing the difference is it's coming via 30.0.0.1. So let us check now whether the IP route or the static route configuration is working between these routers. So let me ping from this PC to this PC and check whether the static route is working. So I would open the command line of this PC and first of all ping my default gateway. So the default gateway is nothing but my fastnet 0/0's IP address. So let me just ping. So it says successful, reply is successful. Now let me just ping the serial interface which is associated in my router, that is 30.0.0.1. The ping attempt is successful. Now let me just try pinging the serial interface of R2. The serial interface which is there over here of R2. Let me just try pinging it to 30.0.0.2. Yes, it is successful. But only thing, if you see, the TTL values are changing. The TTL is nothing but time to live. So every packet has a time frame to live on the network. So whenever it is crossing one router, automatically the TTL value reduces, or one hop. Basically, a packet which is traveling from one location to another location, when it crosses one router or one hop, the TTL reduce. So if you see here, if I want to reach the serial interface of R2, I need to cross one router, that is R1. I have to cross R1 and only then I can reach the serial interface of R2. So the TTL will automatically reduce. The previous ping at command output, if you see, it is 255. In this it will be 254. So let us ping the PC now of R2's network. So it was 2. Initially, if you see here, the first packet would fail and the second packet would be successful. So why the first packet fails? The first packet will always try to understand the routing process. So by the time it reaches the end destination, the TTL might have been expired. So always the first packet fails, but from the second packet, if you see, it would be successful. And the next time if I do the ping, all the packets would be successful. There will be no issue on the TTLs. Now if you see here, the TTL value is 126. Previously it was 255. So for all Cisco devices, it can be a router, it can be a switch, the TTL value would be 255. When it is a PC, the TTL value would be 128. So when you see the TTL value over here, it shows as 126. So why 126? Again, to reach from this PC to this PC, it needs to cross two routers, so two hops. So it is by default 128. When it crosses this particular router, it becomes as 127. When it crosses this router, it becomes as 126. And finally, you see TTL value as 126. So this is a small lab on static route. So I believe this video was informative and thank you for viewing.